Alright, welcome to my latest video, completing the square visually. I'm going to show you how to complete the square without using the formula. So if you want to play along, just have a little patience, and by the end of this video, you'll be completing the square like a master. To help explain some of the numbers in this method, I use a shopping analogy. So I talk about two different parts. One of the parts is how much money you spend shopping, and depending on the scenario, there might be one store, two stores, or even three stores. And the second part is how much money you have in your wallet. So the difference between these two is one of the most important numbers in the process. And once we understand this part, the rest is easy. So before we get into the actual math of it, let's talk about going shopping. Who doesn't love shopping? So let's think that we went on a trip and it cost us $16. Now, notice 16 is a perfect square. We'll get to that later. So there's three different scenarios that happen. The first one happens is that you go shopping and you find $5 in your wallet. So if you spent 16 and you only found 5, what's the situation? That's right, you're going to owe somebody $11. If you look in your wallet and you spent the same amount of money, $16, but you find $20 in your wallet, woohoo! We are now up 4. And what if you go to your wallet and you realize, oh no, I already owe somebody else $10. What's your financial situation going to be? You're going to be minus $26 in the hole. And the last situation, which would be you spend $16 and you find $16 in your wallet. So how much money do you have left over? 0. So please review these 4 situations because this forms the whole basis for the way I teach completing the square. So let's have a look at the structure I use for completing the square. I use a grid because I love working with grids and it links directly to the algebra tiles that we used in previous topics in math class. So let's just take a look at this for a minute. We call this process completing the square because we're actually making a square. So this will be your x squared tile. In this case, we have 6x. So if you think about algebra tiles, if you're making this for factoring, for example, you would split these up. You would put 3 there and 3 there. So then we would ask ourselves, well, if we're making little positives, what would go here? Well, 9 little mini squares of units. That's the basic setup for this question. So I would ask myself, well, if I went shopping and spent $9 and I look in my wallet and I find $3, what's my financial situation? Well, I am out $6. So the way this works is when we're using algebra tiles, we would write this as the two products. So this would be x and a 3 up here, and this would be x and a 3. So because it's an x plus 3 squared, we write x plus 3 squared. And because this calculation has to do with the end number, it's minus 6. So that's how you complete the square. And I'm going to go through a variety of examples of even, double, odd, double odd, and even a crazy odd to let you know all the different types of questions that you might see when you're completing the square. But this is the general principle of how it works. So if you're ready, let's get going. All right, let's start with this quadratic x squared plus 8x plus 5. Sorry about that. And let's make a grid. So I always start with my grid. And remember, this is a perfect square. And we fill in what we have. So we know we have 1x squared. We take our 8x's and we split them up into 4 and 4. And we ignore the wallet for a minute. Just ignore that. Then I ask myself, well, what is 4 times 4? Well, that would be 16. So on my shopping trip, I spent $16. Then I check and see, how much do I have in my wallet? Well, I have $5. So unfortunately, I don't have enough money in my wallet to buy my purchase, so I'm minus $11 in the hole. So that's the information I need to write, the equation. So now the equation is going to be x plus 4 squared, because that's where this comes from and that comes from. And if you remember algebra tiles, you remember that the product would be from an x and a 4 tile and an x and a 4 tile, minus 11. So where does the number 4 come from? Well, it's half of 8. And where does minus 11 come from? Well, that's our shopping math. We had $16 we spent. We had $5 in our wallet, which means we're $11 short. Now, I'm not going to get into a lot of details about how to graph this, We can do that in another video, but for now, that's how you do an even question. This is as easy as completing the square gets. All right, let's do a double even question. This one's a little bit more complicated, but not much. So let's have a look at how this works. Let's for a moment ignore what's in our wallet, the -3, and let's split up everything else that we have. So that means we'd have an x squared in one pile, and an x squared in a pile, and 4x's and 4x's in a pile. So I call this metaphor going to two stores. We're going to two stores to go shopping, so we're going to have two values. So let's build our grid. I apologize, these should be squares. We're going to put an x squared. Now what do we put in here? Well, it's not 8 and it's not 4 because we're going to split up our 4's into 2. And 2 times 2 is 4. So I do that again on this side. 2, 2, 4. All right. So now using our shopping metaphor, how much did we spend? Well, I spent $4 at this store and $4 at that store, so I spent a total of $8 at the store. So now I go to my wallet and I'm like, oh, -$3, I'm already in the hole. So what is the answer? Well, I'm out -$11 because sort of a disaster. I spent way more than I have. Just going to move that up. So what is the equation? How does this work? Well, the way I say it is the first number is the number of stores. The second part is the square. And the third part is your financial situation. So in this case, we went to two stores. 1, 2. In each square, they're the same. It's x plus 2 squared. And my overall financial situation is -11. So the answer to this one, to write a little bit neater, is 2x plus 2 squared minus 11. That's how you handle a double even question. All right, let's look at some questions that have odd number of x's. Right here you see a 7. So that changes things a little bit, but not too much. So let's start with our grid. Love this grid. Put in our x squared. And now think about, what did we do before? Well, we took our number of x's and we split them up. So before it was even. Now this time we'll have 3.5 and 3.5. How do we find this number before the number we spent on our shopping trip? Well, that's easy. We multiply the two numbers together. So in this case, 3.5 squared is 1225. Then we asked ourselves, well, how much did we spend? We spent 1225, and what do we have in our wallet? Too bad, $4. So we're short $8.25. So what is the answer to this question? It's x plus 3.5 squared minus 8.25. So just to recap, take your 7x and you split it up into 3.5 and 3.5. You square it, you get $12.25. That's what you spent at the store. $4 is what you had in your wallet. So you're short $8.25. So our final value is x plus 3.5 squared minus 8.25, and we're done. All right, if you understand how this works so far, double odd questions shouldn't be that hard or difficult. So again, let's ignore what we have in our wallet and work with what we have. So if we have two groups, we'd have an x squared and 5x in each group. So you probably guess where this is going. We make our grid. And in this case, we have a 2.5 and a 2.5, which is 6.25. And we would have the same thing over here because we've gone shopping how many times? You got it. 2 times, 2 stores. All right. So now ask yourself this question. How much did I spend? Well, I spent 6.25 here and 6.25 here. So altogether, I spent 12.50. All right, I spent 12.50, and now I have to figure out how much did I have left. Well, I have -$4 in my account, or in my wallet. So that means with the -4 I already have and the $12.50 I just spent, I'm -$16.50 in the hole. That is not good accounting. So the final answer is the same structure as last time. How many stores we go to? 2. What was in each bracket or box? X plus 2.5 squared and minus 16.5. And that's it. All right, let's look at our last question for this program. And I call this a crazy odd question. It's a 3, but it could be any number. So let's just think about this for a minute. If I want to put this into groups of x squareds, I'd have an x squared and 8/3 x in each group. So I want to have 3 groups of those. 8/3 is approximately 2.67, so we can just go with that. What's going to be in each box? Here's where things get interesting. It's going to be half of 2.67, which is about 1.33. If you keep your decimal points while you're doing this, it's probably better. And what is 1.33 squared? It's about 1.78. All right. So, how many times did we go shopping? Well, 3 times. What's in each box? X plus 1.33 squared. Now, here's where things get interesting. How many times did I go shopping? Well, I went shopping 1.78 3 times. And that equals about 5.3. So I spent a total of $5.33. But good news, I have $10. So that means I'm up $4 and about 67 cents. All the decimals here are just close. So this question has 3 stores, what's in each box. This is the product of each store 3 times, and the money I have in my wallet I used once. So that's how it goes. I see I have neglected the negative x in my travels through this, so I'm just going to address that really quickly here. If I split this up, and you'll notice if you think back to our program that this is the easiest question, it's an even number. So I would put a -4 here and a -4. What do you know about a minus times a minus? Well, it's always going to be positive. So guess what? This number is always positive. So the question about how much you spent shopping and how much you have in your wallet doesn't change because we have a negative. What does change is this part here. So this would now be x minus 4 squared. I spent $16 shopping, found $5, I'm minus $11. And how does this affect the overall equation? Well, you know when you're graphing that -4 moves everything right. So that's the only difference, and that doesn't matter if it's a double even, an odd, a double odd, or a crazy odd. The negative only affects this number, so please watch your signs, and happy completing the square.